Right, we've done a lot of multiplying of complex numbers. We haven't really talked too much of adding and subtracting. So these first two columns, we're going to do some adding and subtracting. I want you to think of this as like terms. If you add two x's together, do you add the exponents? No. If you add 2x plus 2x, that's 4x. Right? We don't do anything to the exponents unless we multiply. So this is a problem where we are adding our expressions. How do I know that I'm adding as opposed to multiplying?
There's an addition sign.
There's an addition sign. But you would be surprised the number of students that would want to FOIL this. We are adding, so just add your like terms. 3 plus 2 is 5. 5i minus 4i. 1i or just I. Remember, I is nothing. I is just an imaginary number, a complex number. I squared, though, that's negative 1. We can replace it with negative 1. But this answer is just 5 plus I. How about this one? What are we doing here?
We're subtracting.
Subtracting. So in this case, we're going to have to distribute a negative 1, aren't we? We have a minus or a negative outside of our parentheses, so let's distribute this negative 1. It's going to bring the first parenthesis down, 4 minus 6i. For the second one, I'll distribute a negative 1. Negative 1 times 3 is negative 3. Negative 1 times negative 7i is a positive 7i. Now just combine those terms. 4 minus 3 is 1. Negative 6i plus 7i is 1i or I. 1 plus I.
Is this on the
Huh?
This is like basically
Not quite. I want you guys to try this one if you would. I'd like for you to try this one, please. The first thing we should do in this example is distribute our negative 1. We bring down the first parenthesis. And I'll distribute my negative 1. Negative 1 times negative 2 is positive 2. Negative 1 times 5i minus 5i. Let's combine our terms. 3 plus 2 is 5. 2i minus 5i. Negative 3i. Which is letter B. Any questions about adding or subtracting complex numbers?
How'd you get to 3? Because I got 7.
Did you distribute?
I distributed, and then I think, what did I do? I did 2 plus negative 5, and well, I don't know what I did. I got negative 5 now, or negative 3, but I got 7 first.
Would you, maybe you added these two together?
I think I did.
Be careful, remember, only add the i's together and only add the positives together. You can multiply it, but not add. Alright, this one's up with the word count, but we can work through this. It says, in an AC circuit, the voltage E, current I, and impedance Z are related by the formula E equals I times Z. Find the voltage in a circuit with current 1 plus 4j amps and impedance of 3 minus 6j ohms. Okay, it sounds way worse than this really is. Let's think about our formula that we're given. E equals I times Z. They're wanting us to find the voltage. Okay. What variable is standing for voltage? E. They're wanting us to find E. They give us the value for I, 3 minus 6j. So let's put 3 minus 6j in for I.
Oh, current I.
And Z, the value for Z is 1 plus 4j.
Actually,
So you go backwards.
yeah, you have to go backwards. Impedance is going to be Z.
You're right, I did get those backwards, so we can flip it around. It really is going to give us the same answer, but
Yeah, but just to make it.
yeah, to make it right, let's flip it around. There we go. Okay, so now I'm going to simplify the right-hand side. I have a binomial times a binomial. What method do we use to simplify that? FOIL. Now, before we FOIL, can I use a shortcut of F and L, first and last? No. When is the only time we can use that shortcut? When they're conjugates. Are these the exact same thing? With only the sign different? No, those aren't conjugates. So we can't do the shortcut. We're going to have to go ahead and FOIL all the way out. So let's start with our first terms. 1 times 3 is 3. O is outside. 1 times negative 6j. Negative 6j. I stands for inside. 4j times 3. 12j. And L stands for last. 4j times negative 6j. Squared. Negative 24j squared. Okay, so let's go ahead and combine our terms. Negative 6j plus 12j. 6j. What if that j squared had been an I squared? What would you be able to do? Make it negative 1. Okay, they are, in this problem, they didn't tell you this, but they are assuming that j and j squared, those are complex numbers. So let's go ahead and assume that this is a complex number here with j squared. Right. So let's replace it. With negative 1. So negative 24 times negative 1 is positive 24. And then from here we can add 3 plus 24. (27 plus 6j). Any questions on this example? Let's look at this one then. We have 5i divided by 3 plus 2i. Okay, we learned that we can't have a radical denominator, right? We have to rationalize the denominator. The same thing applies for a complex number. We can't have a complex number in our denominator. How many terms do we have in our denominator? 2. What would you predict that we need to multiply by? The conjugate. And what is the conjugate of 3 plus 2i? 3 minus 2i. To simplify this expression, to get rid of the I, the complex number of the denominator, we need to multiply by the conjugate. Let's go ahead and do that. You need to do it, multiply by the conjugate in both the numerator and denominator. In the numerator, I'm going to distribute a 5i. 5i times 3, 15i. 5i times negative 2, negative 10, I squared. Now in our denominator, we're taking a binomial times its conjugate. Do I have to FOIL all the way on this one? No, we can use a shortcut. We know in FOIL, if we're multiplying by a conjugate, that the O and the I are going to cancel. So we can skip that multiplying of the O and the I. We can just multiply the first and last terms. So if you multiply the first terms, 3 times 3 is 9. And 2i times negative 2i, negative 4i squared. Is there anything we can do to simplify this?
We can put in negative 1.
So let's turn in the i's squareds to negative 1. We've got 2 of them. So we have 15i minus 10 times negative 1, and 9 minus 4 times negative 1. So we have 15i plus 10 and 9
Plus.
4. 15i plus 10 divided by 13. Can I take 15i plus 10 and say that's 25i? Why not? Not like terms. Just like we couldn't take 15 radical root 6 plus 10. That's how I like that. Let's try another one like this. We'll do this one together. So we have 3i divided by 1 plus I. Once again, we have an I in our denominator, which we can't have. There's two terms in the denominator. What do you suggest? Multiply by the conjugate. I agree. And what's the conjugate of 1 plus I? 1 minus I. So it looks like in the numerator we'll distribute 3i. 3i times 1 is 3i. 3i times negative I, negative 3i squared. And the denominator we're multiplying by the conjugate. Can we do the shortcut? Binomial times a binomial, we're multiplying by the shortcut. We can. So we can just do f and l. 1 times 1 is 1. I times negative I, negative I squared. Okay. We do have these I squared, which we can replace with negative 1. Go ahead and simplify. We have 3i plus 3 divided by 2. Which of these answers is the same as mine? Which one? A is. And an example A or answer A, they've just broken apart the fraction. They have 3i divided by 2 plus 3 divided by 2. And they've actually flip-flopped those around, which is fine. It's the same thing. It's just familiar. What if I gave you that example? What would you do to simplify? Multiply by the conjugate, I agree. Times 3 minus I. So in our numerator, how am I going to simplify? How am I going to simplify the numerator? What? We're going to have to FOIL. How do I know to FOIL as opposed to distribute?
Because there's two terms up top.
Yeah, we've got two terms. Very good, guys. We have two terms up top, so we're going to take it times the two terms over here on the right. We do need a FOIL. So multiply your first terms. 2 times 3 is 6. Outer terms, 2 times negative I is negative 2i. Inner, 3 times I is 3i. And I times negative I is negative I squared. I couldn't use the shortcut in the numerator because the numerators are not conjugates, are they? The denominators are conjugates, so I can't use the shortcut in the denominator. 3 times 3 is 9. I times negative I is negative I squared. Clean up the numerator a little bit. We have 6. I'm going to go ahead and combine these terms here. Negative 2i plus 3i, positive 1i, or I. Minus, I can also replace I squared with negative 1. Denominator, I can replace that I squared with negative 1. So we have 6 plus I plus 1. So it looks like we have 7 plus I divided by 10. If you could simplify, I would want you to do that at this point. I don't think there's anything you can do to simplify this particular problem. Couple more. about this one? We have an I in the denominator, which we know we can't have. There's not two terms in the denominator, so I can't multiply by the conjugate. Think about what our goal is. Our goal is to get rid of the I in the denominator, correct? What can I multiply 2I by that will get rid of I? I. If you take 2I times I, isn't that going to give you 2I squared? Or 2 times -1? Obviously that is. So that's the approach I would take. I would multiply by I. Now, somebody said -2I. You could do that, multiply by -2I, but then in the end you're going to have to divide by -2. I make it easy to just multiply by I. So we will have to distribute I in the numerator. I times 5 is 5I. I times I squared. And the denominator, I have 2I times I, which is 2I squared. Let's change our I squared. Let's replace those with -1. Questions on this example? Let's talk about this one. This will be our last one. Once again, we've got I in the denominator. We'll say we can't have I in the denominator. So what might you multiply by to get rid of the I? What do you say? I agree. Because if you take 2I times I, it's going to give you 2I squared. Which will work for us. Multiply the denominator and numerator both by I. So the numerator will have to distribute. I times 3 is 3I. I times 2I is 2I squared. In the denominator, we have 2I times I. 2I squared. What can we change those I squareds into? -1. So 3I plus 2 times -1 divided by 2 times -1, which is which of these answers on the left there is the same as our answer on the right? I don't believe D is the correct one.
No, it's B.
It's B. It's B. This is going to give us -3/2, okay, which is what we have here, -3/2. And -2 divided by -2 is going to give us +1. Right. We have simplified some complex numbers today. Using similar properties, similar methods that we did with radicals. Remember, if there's only one term in the denominator, just multiply by I. If there are then 2 terms, what are you going to multiply by? The conjugate. Another reminder, if you are subtracting 2 binomials or 2 complex expressions, be sure to distribute that -1 before you combine their terms. Okay, I do have some problems for you to practice out of your book. We will grade this assignment tomorrow, and then we will take a quiz, so be ready for that. We're on page 280, 281. Number is 11 through 17. 6 to 35, and 61.
I put 6 on it. I'm freaking.
If you want to group up and work, you can, but let's get started.